Hello, welcome to my channel. This is just a quick video to show you what I had to do to make GNU Radio Companion work with the HackRF1 SDR receiver module on Debian 13, which is running on a virtual machine on a Proxmox hypervisor so that I can remote control it. And that did add one small complication when I've got the solution to that. So first thing to do, I found it's actually in the software store, GNU Radio Companion. If you search for that, you can install it. I'm not going to go through the process of installing things or setting up the receiver itself. I just want to show what you need to do to make it actually be able to work. So I installed it from the software store on Debian 13. And having done that, then of course we have to go to the terminal. And I ran into a slight problem because normally I use sudo to run the GNU Companion software so that it can access the HackRF, otherwise access is denied to that external USB device, which is passed through the Proxmox hypervisor to this virtual machine. That gave other problems in the virtual machine. So the answer was to run it as a normal user, not root, but then of course it can't access the HackRF. So what you need to do, hopefully you can see this, is to create UDEV rules for the HackRF to enable it to be accessed. So I've already got this command in here, so let's look at what those look like. I'll post those in the description of this video. So you need to put these rules into the virtual machine, and then it can access this HackRF SDR device plugged in via USB. Just do Control X to get out of that. Don't need to save it because it's already saved. So you have to create those rules, and then you have to check that your user is a member of the UDEV group. So you type groups, and not UDEV, I mean plugdev group for pluggable devices, because normally this might be barred for security reasons. So the normal user without sudo privilege can now access the USB devices plugged into the virtual machine. This, I think, it was installed by default or set up by default because this is a fresh install of Debian 13 and that was already there, so I didn't have to add my user to this group. What do I do next? Having created those rules, you need to load them because they won't be loaded. You just save the file, so you have to use the UDEV admin control reload rules to reload them, and then you have to replug the HackRF device. If it's already plugged into the virtual machine, you need to unplug it physically with the USB cable and then plug it back in, and then it should be accessible. So having done all of that, what you need to do next is to start the GNU Radio Companion program, which I do on the command line just here. You see there's no sudo because that caused problems. So now it's just started as normal user. The user is called user, surprise, and it doesn't give up any nasty errors, which it was doing before. So it's loaded the HackRF1 firmware 2.2 on the device. Remember, my HackRF1 is actually in a porter pack, so you have to switch it to HackRF mode to be able to access it via USB and use it from software like this. Otherwise, it's using the porter pack firmware on the device, which is not what you want. So it's running, and all I'm going to do is using Alt-Tab. Yes, I am. I'm going to switch to the program that's already running. Well, let's save that. I'm going to hit Control S because I've modified it a bit. That star's gone away now. I have to remember to do that. So I'm not going to go through how to set up this receiver. There's a very good tutorial on the HackRF website, which I'll link below, from the manufacturer and designer, at least, of the HackRF device. So he tells you how to set this up. It's a little bit tricky, and for me it all depended on the very last stage, the audio sync. That's the output to the audio server on Debian 13, which allows you to hear sound from the loudspeakers. And took me quite a while yesterday to work out that you have to use a sampling rate of 48 kilohertz, and on Debian 13 it seems I need to give my device name that. You can search for what that is on your system and put in the right string here to make it accessible. And that took me a while to work out. And so this is done and it works. But then this 48 kilohertz sampling rate affects the blocks that come before it, because you need to take the sampling rate of the HackRF, which is 2 megahertz, because I want to see a 2 megahertz wide portion of spectrum, and I want to receive narrowband FM signals with a channel width of 12 kilohertz. Makes it easier to say 12 and 12.5, because otherwise it got messy. I had to do a lot of fooling around calculating numbers. So you divide the 2 megs by 12k, and then you come out with something, and you need to use a low pass filter with decimation. And this, actually, I'm showing you how to do it, aren't I? You have to take the sample rate and divide it by the channel width, which is what I was talking about back here in the SDR, and the integer value of that, because it has to be an integer, otherwise you get a number with a decimal point. So this is calculated automatically, and if you look at this, it's actually worked out as 166 that's required. So that 2 megahertz sampling rate's divided by 166. I'm not going to go into all the details too much. And then I had to work out I needed to divide that by 40 to get down to 480 kilohertz. So 480 kilohertz is an integer multiple of this 48k. It's 10 times. So I chose 480. And to get to 480, it seems you need an interpolation of 40 and a decimation of 1. You could also have 80 and 2 would give the same answer, I think. So I set those numbers in there. I had to play around to get this to work. And now it does work. So having done all of that, you can, of course, pause the video and see the layout. It's pretty easy to drag and drop these modules here and connect them up. I've also got a waterfall display, and this frequency sync is a spectral display. It's already running. Normally, you would have to press the start button here. It's already started, so it's running right now. And if I then Alt-Tab to here, this is what pops up on the screen. You get this window pop up, generated by the Python program that you've created from these blocks, and it's showing the frequency spectrum centered on 446 megahertz. Nice place to test, and it's got a width of 2 megahertz because I set the sampling rate to 2 megahertz, which is then read into this HackRF source module called Osmocom as the 2 megahertz. So I can change that number here, and it then propagates all the way through these stages. Center frequency I've chosen is 445, which is not in the center of here, because then you mix it with another signal source to shift it away from the large signal that always appears in the center. It's here. I think you can see it at 447 megahertz. That corresponds to DC at baseband, and it means that every signal you try to listen to will have this big carrier on top of it to make it unintelligible. So I had to fix that as well. So you shift everything, and this is calculated in here. Double click it. So this is the center frequency that's set on here, which is 445 megahertz, minus tuning frequency, which is a variable that I can input. And tuning frequency at the moment gives an offset then of, it should have calculated it, oh, it's 0 at the, oh no, it's minus 1 megahertz approximately. So that, by the process of frequency shifting in this multiplier, then shifts the center up there with the nasty carrier so that I can listen to signals here. And using my tuning range input, this is getting messy already, which is here. Using this module, I've got a slider called tuning frequency. There it is, tuning frequency, and it's currently set to 446.006. That's where the 6 comes from here, because that's channel 1 on the PMR frequency, approximately 446.006. So that is set. I could change it, but I'm not going to. The squelch, I use power squelch. You have to put it, I mean, normally squelch is an audio thing, so you put it in here, which I was doing for a while and it wasn't working. And then I realized that this squelch is not an audio device, it's a baseband device you have to put between the resampler and the receiver to receive this baseband signal at the sampling rate of 48k. When you do that, then it works, and the threshold is currently minus 66 dBs, because minus 66 is about here. So it's above the noise, which means the squelch will close, but most signals are stronger than that. But I can adjust it using a slider squelch, which comes from a variable down here somewhere, that one, called squelch. So the starting value is minus 66. These numbers I had to put in to play around to find out how it works. I haven't reduced them yet. So you can slide the slider and hopefully... Ooh, There we are, there's some nasty noise. I think it's being overdriven at the moment, the audio stage, and maybe these gains are set too high as well. What I'm going to do now is pick up a little handheld radio, PMR radio.
2, 1.
So she's on channel 1, and if I transmit and say hello 1, 2, 3, you can hear that it was received, and you saw the signal pop up and the squelch opened, you heard the audio, and then the squelch closed. So it's working. It's taken me almost 24 hours now to get this going, with a bit of sleeping in between, but I'm really happy. And of course the next thing I want to do is to make the equivalent narrowband FM transmitter as a learning exercise. So I think that's enough for now. Look forward to reading your comments and questions. I'm not an expert, but I'm learning by doing, which somehow is the best way to learn and to let other people see what needs to be done. But as I said, one of the most important things is to set this sampling rate to 48K with that device name so that it can actually output audio. Well, the other thing is on my Proxmox server, this virtual machine is using the SPICE video graphics interface because it also allows copy-paste and it allows audio to come out. You have to add an audio device in the hardware before you set it up so that it can access that audio device, and it actually works. Maybe I should show you the audio device. How would I do that? Let's click up here and go to settings. Now I'm off script, not there, but write a script, sound, and you can see there it is. The output device that it's chosen to use is not a dummy device, which it would be if I didn't have an output device, but it's this Intel ICH9 family. It's emulating a chip. So Proxmox is doing that for me with the SPICE interface, so you can add audio as well. So that's enough. Thank you for watching. Remember to like and subscribe, and let's see what I do in my next video.